Good day. I welcome you all in this lecture on water demand of the subject environmental engineering as per the syllabus suggested by Maulana Abul Kalam Azad University of Technology. The subject code is CE701 and the module number is 1. Myself Sandeepan Saha, Assistant Professor for the Department of Civil Engineering of Greater Kolkata College of Engineering and Management, JIS Group. Now let us first proceed to have a look on the topics that we are going to cover in this lecture. That is water demands, per capita demand, variations in demand, factors affecting demand, design period, and population forecasting. Water supply system is the infrastructure for the collection, transmission, treatment, storage, and distribution of water for homes, commercial establishments, industry, and irrigation, as well as for such public needs as firefighting and street flushing. Of all municipal services, provision of potable water is perhaps the most vital. Potable water, also known as the drinking water, is a water that does not represent any significant risk to health over a lifetime of consumption, including different sensitivities that may occur between life stages as defined by the World Health Organization 2017 report. The World Health Organization considers access to safe drinking water a basic human right. About 1 to 2 billion people lack safe drinking water, a problem that causes 30,000 deaths each week. More people die from unsafe water than from war, as stated by UN Secretary General Ban Ki-moon in 2010. So, as you can see, people depend on water for drinking, cooking, washing, carrying away wastes, and other domestic needs. Water supply systems need to meet requirements for public, commercial, and industrial activities. In all cases, the water must fulfill both quality and quantity requirements. Let us proceed to the quantity aspect of water supply, which is also known as the demand for water or simply water demand. If a total volume of water, that is V, liters or million liters, is supplied to a place annually, then the daily average supply is V by 365. That means the total volume of water V is divided by the 365 number of days, as a year consists of only 365 days. Henceforth, the daily average supply of water per head, which is also known as per capita demand, expressed as small q, can be calculated as V by 365, which is already we know that is the daily total supply of water, which has to be divided by the total number of heads. So basically, this amount of water needs to be supplied for each head daily to meet the daily needs, that is drinking, for cooking, for washing, etc. The per capita demand, which is also known as the rate of demand or simply LPCD. LPCD stands for liter per capita demand or liter per capita demand or liter per day per head. As we know that the per capita demand is the amount of water needed per head on a daily basis for various daily needs, but this amount varies depending upon certain various factors, which are as follows. The first one is size of the city. Per capita demand for big cities is generally large as compared to that for smaller towns, as big cities have sewered houses, presence of industries. If industry is high at a certain place, then definitely water demand is high, as to run a certain industry, requirement of water is high. Then comes the climatic conditions. If it is hot climate out there, requirement of water is high. Now the habits of people and their economic status. As the areas with higher incomes generally use more water than areas with low incomes. Larger landscaped residentials lot that require more water are often associated with more affluent communities. Additionally, higher income households may be less sensitive to the cost of water since it represents a very smaller portion of household income. Now the factor is quality of water. If water is aesthetically and medically safe, then the consumption will increase as people will not resort to private wells. The next important factor is pressure in the distribution system. If the pressure is high in the water distribution system, that means supply of water is great and high, which is automatically turned out to be the reason for high water demand. Now comes the another important factor is which is efficiency of water works administration. Leaks in water mains and services and unauthorized use of water can be kept to a minimum by regular checks and surveys. The last important factor in our list is cost of water. Water prices can influence demand of water by providing a monetary incentive for customers to conserve water. Rate structures have been established in many places to incentivize the water conservation concept, but the effectiveness of these rate structures to determine the excessive use and customer sensitivity to water prices may vary. There are several types of water demands which a city may have and may be divided into the following types: domestic water demand, industrial and commercial water demand, demand for public uses, fire demand, water required compensating losses in wastes and thefts. The first one is the domestic water demand. This is the amount of water required in private buildings for drinking, cooking, bathing, lawn sprinkling, gardening, sanitary purposes, etc. This amount varies according to the living conditions of the consumers. On an average, this domestic consumption under normal conditions in an Indian city is expected to be around 135 liters per day per person, as per the Indian Standard 1172 of 1971. The total domestic consumption generally amounts to 50 to 60% of the total water consumption. As it is already mentioned that an average daily consumption under normal conditions in an Indian city is expected to be around 135 liters per day per person. Here is the details usage list of 135 liters per day per person, which is as follows. For drinking purposes, around 5 LPCD amount of water is required. LPCD means liter per capita demand. For cooking purposes, 5 LPCD is required. For bathing purposes, around 55 LPCD is required. For washing of clothes, 20 LPCD of water is required. Washing of utensils, 10 LPCD of water is required. And for washing and cleaning of houses, 10 LPCD of water supply is required. And for the washing and cleaning of residences, 30 LPCD of water supply is required. Altogether, the daily domestic water consumption is around 135 LPCD, that is 135 liter per capita demand, which is required for the daily purposes per head. Please keep that in mind that this 135 LPCD is required for per head purpose on a daily basis. The following table deals with the average domestic water consumption per head in an Indian city based on the total number of population. The first one is for the communities with population up to 20,000 and without flushing system, and it can be categorized into two parts. The first one is where water is supplied through stand post, and in this case the required amount of water supply is 40 LPCD. And the second part is where the water is supplied through house service connections, and in this case around 70 to 100 LPCD amount of water is required. The next is for the communities with population in between 20,000 to 1 lakh with having full flushing system, and in this case the required water demand is around 100 to 150 LPCD. And the third one is for the communities where the population is more than 1 lakh having full flushing system, and for this case the required water demand is around 150 to 200 LPCD. As you can understand that with increasing number of populations, the requirement of water demand is getting higher. Here is the point to be noted that the values of water supply given as 150 to 200 liter per day per head, that is, I am talking about this thing, this portion. This may be reduced to 135 liters per head per day for houses for lower income groups and economically weaker sections of society, depending upon prevailing conditions. And this information has been acquired from the code, that is Indian Standard of 1172 of the year 1993. The following table depicts the daily average domestic water consumption per head in an Indian city based on the type of city. The first one type is towns provided with pipe water supply but without sewerage system, and for this case the required and recommended water supply is 70 LPCD. The second one is the cities provided with piped water supply and where sewerage system is either existing or contemplated, and for this case the recommended water supply is around 135 LPCD. And the third case is for the metropolitan and mega cities provided with piped water supply where sewerage system is either existing or contemplated, and for this case the recommended water supply is around 150 LPCD. There is a point to be noted that in urban area where water is provided through public stand posts, for this case 40 LPCD should be considered as water supply, and this information has been acquired from the Manual on Water Supply and Treatment, May 1919, as suggested by the Central Public Health and Environmental Engineering Organization, that is CPHEEO. Let us have a look at the water demand required for the industrial and commercial purposes, and this includes the quantity of water required to be supplied to the offices, factories, different industries, hospitals, hostels, etc. And these kind of buildings can be categorized under the industrial and commercial purposes. This water demand will vary considerably under the nature of the city and with the number and types of industries and commercial establishment. But there is no direct relationship of the consumption with the population, and hence the actual requirements for all industries should be estimated. The water requirements for buildings other than the residences as per IS 1172 of 1973 standards are as follows. Here I have mentioned several industrial and commercial institutes, and here the list of water requirements as per the IS 1172 of 1973 standards for commercial and industrial purposes. The first one is hospital. Having bed number more than 100, the required water supply is 450 liter per bed per day. So it's not measured in liters per head per day. And the hospitals having beds less than 100, the required water demand is 340 liter per bed. For hotels, the required water supply or water demand is 180 liter per bed per day. So you can see that for the first three cases, the water supply is measured in liter per bed per day, but not in liters per head per day. Now we come to the hostels, and for this purpose the required water supply or water demand is 135 liter per day per head. For nurses' homes and medical quarters, the required water supply is 135 LPCD. For boarding schools or colleges, the required water supply or water demand is 135 LPCD. For restaurants, the required water supply is 70 liter per day per seat, not LPCD. For airports and seaports, the required water supply is or water demand is 70 LPCD. For junction stations and intermediate stations where mail or express stoppage is provided, the required water supply is 70 LPCD. For terminal stations, the required water supply is 45 LPCD. And for the intermediate stations, the required water supply is 45 LPCD. For the day schools or colleges, the required water supply is or water demand is 45 LPCD. For offices, the required water supply is 45 LPCD. And for the factories, the required water supply is 45 LPCD. If there is no bathroom is provided, then this particular 45 LPCD amount can be reduced to 30 LPCD for the case of factories. And for the institutes or buildings like cinema, concert halls and theaters, the required water demand is 15 LPCD. Here, specifically, the water demand for various transportation centers has been discussed, as transportation centers are important commercial institutions. Here, the transportation centers are categorized into two different sectors. The first one is railways, bus stations and seaports, and the second one is airports. The first one, that is the railways, bus stations and seaports, are further categorized into three different types. The first type is intermediate stations, excluding mail and express stops. In this case, the required water demand is 45 LPCD, where bathing facilities are provided, and 25 LPCD, where bathing facilities are not provided. In case of junction stations and intermediate stations where mail or express stoppage is provided, the required LPCD, the required water demand is 70 LPCD for bathing facilities are provided, and if bathing facilities are not provided, then the required water demand is 45 LPCD. And for the terminal stations, if bathing facilities are provided, then the required water demand is 45 LPCD, and if no bathing facilities are provided, then the required water demand is 45 LPCD. And the second important category is airports. For both the international and domestic airports, the required water demand is 70 LPCD, where bathing facilities are provided, and 70 LPCD where no bathing facilities are provided. And these informations are acquired from the Code of Basic Requirements for Water Supply, Drainage and Sanitation of IS 1172 of 1993. Now, let us come to the demand of water for public users. This includes the quantity of water required for public parks, gardening, washing and sprinkling on roads, use in public fountains, etc. A nominal amount not exceeding 5% of the total consumption may be added to meet this demand on an arbitrary basis, or else the consumption of water for municipal purposes can be considered as given below. For public purpose, for the purpose of public parks, the water consumption can be considered around 1.4 liters per meter square per day. For road watering, the water consumption can be considered as in between 1 to 1.5 liters per meter square per day. And for sewer cleaning purpose, the water consumption can be considered as 4.5 liters per head per day. Now let's come to the firefighting demand. Extinguishing for fire is very small in a year, but the rate of consumption is large. The scheme should provide the necessary peak demand of water for firefighting. The water requirements for extinguishing fire depends on bulk, congestion, and fire resistance of buildings. Indirectly, we can say it mainly depends on the population. The minimum limit of fire demand is the amount and rate of supply that are required to extinguish the largest probable fire that may occur in a town. The per capita fire demand is very less on an average basis, but the rate at which the water is required is very large. The rate of fire demand is sometimes treated as a function of population and is worked out from the following empirical formulas. These formulas are standardized by various international authorities. The first one is the American insurance formula. As you can see, the formula is Q equals to 4637 root over P multiplied by 1 minus 0.01 root over P, where Q is the required supply rate of water during firefighting measured in liter per minute, and P is the population measured in thousand. Suppose a sector has a population of 1 lakh. Then putting the value of P in the formula, we are putting the value of P in this formula, and then we can get the required supply rate of water, that is 41760 liter per minute. There are other formulas like Cushing's formula, Freeman's formula, Ministry of Urban Development manual formula, where putting values of P, that is population, we get the required firefighting demand. Here, as for the Ministry of Urban Development manual formula, this formula is applicable where the population is more than 50,000, and Q, that is the supply rate of water during firefighting, is measured in kiloliters per day. Now let us have a look on the water demand required for compensating losses in wastes and thefts gross water demand for the project service area can be computed by adding the domestic and non-domestic water demand assessed and also considering the losses in the water treatment plants, transmission mains, and the local distribution networks. Present day leakage losses in the local distribution networks in most of the Indian cities are very high. In a few typical cases, 40% of the losses have been reported. In major metro cities, leakage monitoring operations and repairs to reduce leakages are in the ongoing stage, and future water demand projections should consider reduced leakages as the consequences of the above activities. In any case, it would be almost impossible to have financially viable projects if the future leakages are not controlled by above mentioned measures. A typical future target could be 15% losses in the local distribution network, which could be considered in projecting the gross water demand, though at times the financial institutions might prefer 10%. Fluctuations in rate of demand. As we have already discussed that the average daily per capita demand equals to the quantity required in 12 months divided by 365 days divided by the total number of population. If this average demand is supplied at all the times, it will not be sufficient to meet the fluctuations as follows. Seasonal variation. The demand peaks during summer. Fire breakouts are generally more in summer, increasing demand. So there is seasonal variation. Daily variation. It depends on the activity. People draw out more water on Sundays and festival days, thus increasing demand on these days. Hourly variations. These are very important as they have a wide range. During active household working hours, that is from 6 to 10 am in the morning and 4 to 8 pm in the evening, the bulk of the daily requirement is taken. During other hours, the requirement is negligible or not that much. Moreover, if a fire breaks out, a huge quantity of water is required to be supplied during a very short time, necessitating the need for a maximum rate of hourly supply. An adequate quantity of water must be available to meet the peak demand. To meet all the fluctuations, the supply pipes, service reservoirs, and distribution pipes must be properly proportioned. The water is supplied by pumping directly, and the pumps and the distribution system must be designed to meet the peak demand. The effect of monthly variation influences the design of storage reservoirs, and the hourly variations influences the design of pumps and service reservoirs. As the population decreases, the fluctuation rate increases. The maximum daily demand can be computed as this formula, that is 1.8 times the average daily demand, and the maximum hourly demand of maximum day, there is a peak demand, can be calculated as per the following formulas. Now let us have the calculation process of water quantity estimation. The quantity of water required for municipal uses for which the water supply scheme has to be designed requires the following data. Number one is water consumption rate, that is the per capita demand in liters per day per head, and number two is population to be served. So if we do the calculation of multiplication between per capita demand and population, then we get the quantity of water which is to be served to the city or the sector. So in this lecture, we have learned about various kind of water demand which are very important in designing a water supply scheme. In our next lecture, we will focus on population forecasting methods along with design period required for a water supply scheme. Thank you.